Hi everybody, and welcome to the first instalment of the 3 Degree of Freedom Motion Platform Simulator build. Today we're going to talk about how I've built it, why I built it the way I've built it, and the materials that you're going to need to build this. I've built this 3 Degree of Freedom Motion Platform personally for myself so then I can get deeper immersion in my racing sim games, which is what I enjoy playing. These are all played on PC. They include racing sims like Assetto Corsa, R-Factor 1 and 2, iRacing, Forza Horizon, etc. Now, if you have a Xbox platform or a PlayStation platform, this motion simulator may work for you as well, but you would have to probably do a little bit of research on xsimulator.net. I believe I have seen some stuff on there regarding some kind of porting to get a motion simulator to work with those platforms, but really specifically this build and all the wiring and the software that we will talk about and learn how to do for this motion platform is based on a PC application. Okay, let's have a very quick look at my motion platform. So this is where we are at the moment with this build. Please don't be put off by this. You have to sort of imagine by the end of the build, this will be all painted. I'm going to do this in some really nice racing red, probably in the top frame, and black in the other parts to make it look really quite snazzy, to make it look a little bit like my 1969 Ford XW. Okay, so this is a basic overview of my motion platform and how I built it. Now, you will be building this slightly different with the materials I'm recommending that you build yours with, because I built this from materials that I had on hand to save me having to buy a whole bunch of material. So the most weird thing really is the top frame. This is an old trampoline frame that was left over from a trampoline that my kids used years ago, and I kept the ends of it. And these are the ends, the two ends of the trampoline that I brought together, MIG welded, and turned into my frame. You will be using a different material for this because although this was good for me, I'm going to get you to build yours in box, and it'll be a lot easier for you to build. So I'm going to help you out in that way, and I'll give you what you need to know, the dimensions that you're going to need to know to build that as we go through our build. So really today is just about the absolute fundamentals of what you're going to need in materials for your 3 layers to build your 3 Degrees of Freedom Motion Platform Simulator. Now I've made a list here so I can so I don't get sidetracked, and I'll refer back to my motion sim as I go through these, so then you'll understand why you need them. But you are going to have to trust me to buy this stuff, and because it's what you're going to need if you're going to build your motion platform sim based on my design. So let's talk about a top frame. Like I said, mine is built from that trampoline pipe. You're going to build yours, okay, with 30 by 30 millimeter by 3 millimeter thick box. Okay, that's what your frame, that your seat, that your steering wheel frame, that your pedals, all of those peripherals will be off that frame. So you need to purchase 30 millimeters by 30 millimeters by 3 millimeters thick. Get 3 millimeters. Don't cheap out and get 1.6 or 2. This has to hold all your weight. Get a 3 millimeter thick box, and then you won't need to do a whole bunch of bracing. It will hold itself because it will be strong. Okay, you will need to purchase, and you will need 6 meters of that. You will need 6 meters in total, okay, of 30 by 30 by 3 millimeter box. You will then need to purchase 35 millimeter by 35 millimeter, again, 3 millimeter thick box. You'll need 2 meters in total. This is this guy here. Now what this will do, this is going to be your slide over material. So it goes over, if I can get it to go, it goes over our 30 millimeter, and that's going to incorporate this type of arrangement here. So then all of your steering wheel frame is movable. So in my design, my seat is static, okay, but I can move my steering wheel frame with my steering wheel back and forwards and its height can be adjusted up and down. What you're going to use, the way I've had to set this up for mine, you won't have to do this. You'll have your 30 by 30 box, and you'll just have your 35 by 35 millimeter box able to slide over your 30 millimeter box to do this. And we'll talk about that when we get to the build on that. So we'll talk about all these things in detail and how you do it, but you just need to buy these materials for us to get to that point. Okay, you will need to buy 25 millimeter by 25 millimeter by 2 millimeter box, 5 meters in total. That is your steering wheel frame, shifter frame. That is your framing across your main frame for your seat to sit on, as well as your uni joint to top frame connecting points, which are, you can just sort of see some flat steel there going between the 25 by 25, where our uni joint is bolted to our top frame. That's what you need that for. Okay, our pedal plate, rightio. So if you can get 500 by 500 millimeter, 1.5 millimeter sheet cut. Now you may, when you go to your metal merchant to buy all of these supplies, he should be able to guillotine that. If you go to a genuine, if you're not just going to like a Walmart or a Bunnings or something like that, go to a proper metal supply shop. They'll have the guillotine, and they will be able to guillotine. I would think they should be able to guillotine 500 by 500. They may operate in minimums of 1 meter's lengths for everything, including plates. So you may have to get 1 meter by 1 meter, and then you'll have to cut it to size, and we'll go through that when we get to the build. But you need to get a minimum of 500 by 500 millimeter by 1.5 millimeter thick sheet. Okay, and that's what our pedals are sitting on. That's what they're bolted to. Okay, you'll need that. You'll need 10 millimeter by 10 millimeter square solid mold carbon steel. So that's this guy here. Okay, 10 millimeter by 10 millimeter. That's used in a lot of different things in this build for bracing. That actually, let me have a look. Have I written that down? No, I haven't. So I'm just going to go through it. Okay, so that's also incorporated into the pedal plate, into its build. That's what gives the pedal plate the strength and the bracing. That's why you can get away with only a 1.5 millimeter bottom, because really the pedals are just sitting on that. It's the 10 by 10 that gives you all the strength in the pedal frame. Okay, it's also used as a little bit of a brace here on our shifter mount. Okay, it's also used, even though this is round, I just used that because I had some surplus round lying around. You will use this 10 millimeter by 10 millimeter. It's a bracing for our caster wheel, for want of a better word, axle plate. Just trying to think. Yes, we've also got where our seat sits on our main frame here. There's a piece of that 10 millimeter by 10 millimeter solid steel that runs across underneath the front of our seat to give our seat, because your seat is going to sit down inside your frame, so then you sit nicely back into your seat, and it needs to be supported at the front, and we support that with a 10 millimeter by 10 millimeter piece of solid, 10 millimeter by 10 millimeter square solid, 5 meters in total. Get 5 meters. Now I'm basically, for all of this material, I'm actually overstating what you need, not by very much, but by a little bit, because trust me, even with years of experience, it's very easy to make mistakes. So if you've got a little bit more material at hand, then you've got a little bit of wriggle room to be able to start over or repair things, because you will be welding. And it's great being able to weld, because it means that if you make mistakes, you can fix them. But you won't be able to fix them if you don't have a little bit of extra material on hand. So all of my estimates for your material are a little bit over, so you've got a little bit of wriggle room. 140 millimeter by 5 millimeter flat steel, 1 meter in total. Now that's for our steering wheel mount plate. Okay, that guy there, 140 wide, 5 millimeter thick. Now this is actually only 320 millimeters in length, but I doubt you'll get that. You'll have to, I would say, buy a minimum of 1 meter, but don't panic, because you will use that again. When we get into the details of what you're going to purchase, the tools I'm talking about, right? So any surplus metals that you have, trust me, down the track, when you've become more competent with the tools you're going to use, you will use this surplus metal to build other projects. I know you will, because I know you guys that are watching this, I know you're all OCD and you're all ADHD. Moving on. 50mm by 8mm flat steel. 2 meters in total. Kevin, turn over. Okay. Front motor rod connectors, traction loss, push rod bracket. So what we're talking about here is this material right here, friends, okay? 50mm in width, 8mm in thickness. It's a heavier steel because it's taking the forces from our traction loss motor, which push our mid-frame, which give us our yaw on our mid-frame. So it has to be strong and it has to be braced, right? It has to be braced and it has to be strong. This is also used for our front motor, our front rod connectors to our top frame. 5mm by 50mm width, okay, flat steel, 2 meters in total. 75mm by 5mm flat steel. And we'll probably go over this twice because this is also the major component in our bottom plate. So that is used for our bottom plate that our traction loss runs on. It is used for our uni joint to connect to our top frame. There's 2 pieces there sandwiched, bolted together. So that's the other important thing to keep in mind with the way I've designed this motion simulator is every layer can be taken apart relatively easily if you need to move this simulator to a different room, or you're moving house, or whatever the issue may be that you need to pack this thing down. You will be able to separate this and move it, okay? And it's still actually a relatively small footprint for what you're going to get in this build. Anyway, you just need to know that you need to get 4 meters of 75mm by 5mm flat steel. 4 meters. Don't skip on that or you will be sorry. You will need to find yourself some 16mm outside diameter and 13mm inside diameter by 2mm in thickness wall, so the wall needs to be 2mm thick, pipe. We're using that to make a whole bunch of conical spaces, right, for our tie rod bolt connectors for this sort of scenario. Okay, so then it gives our tie rod plenty of wriggle room. We also use that to brace our seat at the back here, so then it doesn't crack. Now, I will probably elaborate on this. I may get a piece of, if we have some surplus 75mm by 5mm thick flat steel, this stuff here, we may use that and incorporate that into this just to give this whole section here a little bit more bracing, though you probably don't need it. That is strong as the way that it is actually welded, braced in itself, and then it braces the seat. It's strong as. So it'll probably be all right just on its lonesome. On its lonesome. Right. 140mm by 20mm by 4 meters in total Merbau decking. Now this is the little piece of gold that's going to save you guys a lot of work with having to pull apart your windscreen wiper motors, which we're using and we will talk about in depth in a second. This is going to keep all of those motors separated from each other as far as a circuit goes and as far as wandering current goes, so you don't damage your IBT2 motors or have any potential to damage your windscreen wiper motors. A lot of people take their windscreen wiper motors apart and they isolate the ground. I don't think it's a good idea to isolate grounds in any motor, DC or AC, and there's other people that share that opinion. If we isolate all our motors from each other using hardwood brackets, all the motor peripherals, so our shaft brackets that connect to our top frame, or that push our mid-frame, if they're all isolated from one another, and believe me, hardwood will do, dry hardwood will more than isolate 12 volt DC. That's all that we need to do. Now that is this material here. So this is a decking. This is a hardwood decking. It's called Merbau. You will need to purchase, what did I say? 4 meters. 4 meters of 20 millimeter thick by 140 millimeters in width. Merbau decking, 4 meters. And that incorporates all of our motors to our frame. Now I've checked this whole setup with a multimeter, okay, with a continuity test, and there is no continuity doing it this way between any of the motors. And believe me, that Merbau decking, okay, hardwood, it has to be a hardwood, that is more than strong enough to get the job done for what we need. I've tested this motion rig with the SMC3 utility software. I've already tested all of the axis that I need to test for it to work with me on the sim, and there's no issues. Now, time will only tell with hours of play as to how robust it actually is, but I'm super confident it's going to be fine. Okay, and it's just a little bit of insurance without having to pull those motors apart and then risk cocking up your motors. Now we need to look at our mid-frame. Rightio, our mid-frame is this big hunk of love here, okay? Once again, something that I had on hand, but after giving it some thought, an excellent choice, because it would save us having to buy quite a lot of smaller box. Once again, probably 30 by 30 by 3 millimeter box to make a full square. It'd have to be all braced. If you just buy one piece of this 100 by 50 by 3 millimeter thick box, and you get yourself 2 meters of it, okay, there's your mid frame. Nothing else to do, okay? It's just one piece of metal that we attach all of our mid frame components onto. Done. Get that. It's going to save you a lot of time and help keep you a small footprint. So that's our mid frame spine. 100 millimeters by 50 millimeters by 3 millimeters thick. Get 2 meters. Okay, 65 millimeter by 35 millimeter by 3 millimeter, 1 meter box main front motor bracket. Oh yes, so this is this stuff. Now this is stuff that I had lying around, and that is way over the top, right? That's 6 mil in thickness. I use this to build my car ramps. Okay, I've got a full set of car ramps that all operate on hydraulics. So then I can lift my car, my beautiful 1969 Ford XW Monster muscle car. You won't need that thick of a material. You will need 65 millimeters by 35 millimeters and just get 3 millimeter thick. That is for our front motor mount bracket, okay? This guy here, all right? And there you can see some 75 by 5 millimeter flat that we talked about earlier. That will go into the ends of these that our Merbau attaches to, that our motors attach to our Merbau. Good God, that thing was in the way. Our motors attach to our Merbau. Our Merbau attaches to our bracket here, to our flat steel bracket that is welded on to our 65 by 35 by 3 millimeter thick box, okay? And you also use this same box for your connection from our bottom plate to our mid frame via our caster frame, okay, which gives us which allows our mid frame to pivot. I pinched that off Dave, actually from xsimulator.net. Well, a similar setup, the caster idea I used from him. So shout out to you, Dave. What a bloody legend. Okay, so you will need, in this design, 65 millimeter by 35 millimeter by 3 millimeter. You only need 1 meter of that. Let me just double check. Main front motor bracket plus bottom frame to mid frame swivel connection. I got it. Okay, you'll need 75 millimeter by 8 millimeter, 1 meter in total, caster wheel plate. Ah, yes, okay. We sort of did briefly talk about this. This is our traction loss wheels, okay? They are on 75 millimeter by 8 millimeter thick flat steel, okay? Once again, it's a heavier metal because all our weight is straight over our wheels. So you will also need to brace this. And we will go into all the details of all this and how you do it when we get to the build. This is just the materials you're going to need to make this happen. Now we move to our bottom plate. We've already talked about our 75mm by 5mm thick flat steel, all right? And that is our bottom plate. Once again, it has a spine like the mid frame. Okay, it's got a little 300mm stabilizer attached to the front. This just sits flat on the floor, okay? It doesn't need any twist or downward strength. It's just what the mid frame runs on. It's perfect. It's light, it's perfect, and you don't have to build a full box frame. You just buy some of this flat steel. I'll give you the dimensions when we start getting into the build. And it's quick, it's dirty, but it's easy. Okay, and you're going to need, like I said, 4 meters of that, guy. 4 meters. Now, is there anything on the next page? There's nothing. So that means we can talk about a little bit of the other things that are going to be relevant to this build, and we better make this quick because we're already at 23 minutes. I will be able to edit some of this, but I haven't done a lot of video editing. I'm a little bit tarded when it comes to the video editing, so I want to try and get everything in there so I don't have to do too much video editing. I'll have all the links and everything like that for purchasing our beautiful mining dump truck wiper motors. These guys are 180 watt. They operate between 20 and 25 amp. They operate around 20 to 30 Newton meters. Okay, they're all metal transmission casing. They're a metal worm drive. They're metal gears. They're very strong and very powerful motors. 12 volt DC. They're going to be powered by our 30 amp, 120 volt AC step down to 12 volt DC power supplies. You're going to be running them. You're going to be controlling those motors in the SMC3 software with IBT2 43 amp double H-bridge motor controllers, one of which turned up brand new and didn't work. What a bunch of wops. You're going to use an Arduino Uno control board. That's a clone. Cost me 12 bucks. I think these were like 16 bucks. So one wasn't working. What do you expect for that sort of money? You'll need a project box or something of that caliber. This was just an old metal servo box that I found that happened to fit everything in, because you need to have a fan to keep everything cool and you need to get your power supplies in. I'll give you the dimensions of that in the coming videos. It's very important to note that this build without any of the racing peripherals. So I'm assuming you already have a racing wheel. You already have a steering wheel. You already have a set of pedals, and you already have a shifter. I'm not including those peripherals in what I believe this is going to cost you, and I'm going to tell you what this is going to cost you now. Please do not have a heart attack. So maybe before I tell you this, it might be time to go and grab a cup of concrete, mix it in a bit of water, scull it, harden up, and then hear what I have to say. I estimate that you are going to need to spend around 2,000 Australian dollars to build this sim, motion sim, but that's going to include all your motors, all your electronics and power supplies, all of your materials, all of your fasteners, and all of the tools that you're going to need to build this sim would be included in that $2,000. And we're talking about having to buy a welder here, having to buy a decent angle grinder, and some fairly sophisticated tooling, some not so sophisticated, but some sophisticated tooling to get this job done and make your life a little bit easier building this sim. If you think about that as a long-term investment and not just for building this sim, because trust me, once you buy these tools and you start working with this metal and you start learning to weld, grind, cut, measure, you're going to become addicted to that. Okay, and you are going to already be lying in bed at night thinking, what is my next project? What is my next project? What is my next project? What did I say? What did I say? I said ADHD, and that's a good thing. That's not a bad thing, because I tell you, people with ADHD, they actually get shit done. Okay, so it is a long-term investment. Think about it like that. The cheapest retail 3 degree of freedom motion platform I could find online, shipped to my country here in Australia, would have cost me $3,600 Australian. So you would already be, if you're an Australian, $1,600 better off building your own, and you've got material and you've got tools that you can continue to use for years to come. And you will look back and you will thank Uncle Kevin for convincing you to go ahead with this madness. I just want to say a very quick thank you to all the folks on xsimulator.net, and I would encourage everybody watching this video who are going to have a crack at building this to start frequenting that forum, because there is a vast amount of information on that forum about how to build motion platforms, 2 degree, 3 degree, 4 degree, 6 degree motion platforms. We're doing a 3 degree. Now, I know you're watching this video because I can show you how to build it, but my ideas for building this motion platform simulator in the first place, a lot of that came from that forum. That's where I found out about all the information on how to wire your motors up so then you can control them via the software. That is all on xsimulator.net. The people there are a fantastic bunch. A lot of them have spent a lot of time researching this stuff, working stuff out, and they have freely shared their results, and their hours of research is shared on there for you to also become knowledgeable about this. So get yourself to xsimulator.net and become a member. I'd really appreciate it if you subscribed. I'm helping you out here. Please help me out and subscribe as we go through this journey together of building this awesome 3 degree of freedom motion platform. For everything you're going to need, I'm going to be with you the whole way here. Thank you very much for watching this. I'm sorry the video's gone for so long, but there was a lot to cover. And I'll see you in the next video where we talk about all the fasteners we're going to need to put all of this bad boy together. Okay, rock on, folks.